Hello friends, today we are going to discuss about correlation coefficient, its type and formula. A correlation coefficient is a number between -1 and +1 that tells you about the strength and direction of a relationship between variables. In other words, it reflects how similar the measurement of two or more variables are across a dataset. So correlation coefficient of 1 mean perfect positive correlation when one variable changes with respect to other in the same proportion. Correlation coefficient of 0 means zero correlation. There is no relationship, and when it is -1, this is perfect negative correlation, and when one variable changes, then other variable will change in a negative direction. So if one variable increases, the other variable will decrease. So what does a correlation coefficient tells us? Correlation coefficient summarizes the data and help you compare results between different studies. A correlation coefficient is a descriptive statistics. That means it will summarize the sample data without letting you infer anything about the population. A correlation coefficient is a bivariate statistics when it summarizes the relationship between two variables. And if it is multivariate, then you have more than two variables. If your correlation coefficient is based on a sample data, you will need an inferential statistic if you want to generalize your result to a population. You can use f-test or t-test to calculate a test statistic that tells you the statistical significance of your finding. Comparing studies, a correlation coefficient is also an effective size measure which tells you the practical significance of a result. Correlation coefficients are unit-free, which makes it possible to directly compare coefficients between different studies. So using a correlation coefficient. In a correlation research, you investigate whether changes is one variable are associated with the changes in other variable. Correlational research, you investigate whether standardized score from school children are related to academic grades in the college. You predict there is a positive correlation. Higher school SAT score is associated with the higher college GPA, while lower SAT scores are associated with lower college GPA. After a data collection, you can visualize your data with a scatter plot by plotting your variable in the x-axis and the other on the y-axis. It doesn't matter which variable you place in the either axis. Visually inspect your data from the scatter plot for a pattern and decide whether there is a linear or non-linear pattern between the variables. A linear pattern means that you fit a straight line of the best fit between the data points, while a non-linear or curvilinear pattern can take all sort of different shapes such as U-shape or line with a curve. A visual inspection examples, you can gather a sample of 5,000 college graduates and survey them on their high school SAT scores and college GPA score, and you can visualize data in a scatter plot to check for a linear pattern if there is linear pattern existing or not. So there are many different correlation coefficients that you can calculate. After removing any outliers, select a correlation coefficient that is appropriate based on the general shape of the scatter plot pattern. Then you can perform a correlation analysis to find the correlation coefficient of your data. Your calculation of correlation coefficient to summarize the relationship between variables without drawing any conclusions about the causation. You can check whether the data meet all the assumptions for the Pearson's or correlation test. Both variables are quantitative and normally distributed with no outliner, so you can calculate Pearson's or correlation coefficient. the correlation coefficient is strong, that is, it should be more than 5. So correlation coefficient, correlation strength are related. The value of correlation coefficient always changes between 1 and -1, and you treat it as a general indicator of the strength of the relationship between variables. The sign of the coefficient reflects whether the variable changes in the same or opposite direction. A positive value means the variables changes together in the same direction, while a negative value means they change together in a opposite direction, that if one is increasing the other will decrease. The absolute value of a number is equal to the number without its sign. The absolute value of correlation coefficient tells you the magnitude of the correlation between the variables. The greater the absolute value, the stronger is the correlation. There are many different guidelines for interpreting the correlation coefficient because findings can vary a lot between different studies. You can use the table given here is a general guideline for interpreting correlation strength from the variables. While the guideline is helpful in a pinch, it is much more important to take your research context and purpose into account when formulating conclusions. For example, if most studies in your field have correlation coefficient nearing 0.9, a correlation coefficient of 0.58 may be lower in that context. Visualizing linear correlations. The correlation coefficient tells you how closely your data fits on a line. If you have a linear relationship, you will draw a straight line of the best fit, and that will take all your data points into account on a scatter plot. The closer your points are in this plane, the higher the absolute value of the correlation coefficient and stronger is your linear correlation. So this one figure shows positive correlation and other shows negative correlation. If all points are close to this line, the absolute value of your correlation coefficient is high. So this has the high positive correlation and this has high negative correlation. If there are points spread far from the line, the absolute value of your correlation coefficient is low. This is low positive correlation and other one is low negative correlation. Note that the steepness of the slope the line isn't related to correlation coefficient value. The correlation coefficient doesn't help you predict how much your variable will change based on the given changes in the other, because two data sets with the same correlation coefficient value can have lines with different shapes. So both shapes denotes correlation coefficient is R is equal to 0.58. The type of correlation coefficients. You can choose from many different correlation coefficients based on the linearity of the relationship, the level of the measurement of your variables, and the distribution of your data. For a higher statistical power or accuracy, it is best to use the correlation coefficient that's most appropriate for your data. A most commonly used correlation coefficient is Pearson's R because it allows for strong inferences. It's parametric and measures linear relationship, but if your data do not meet all assumptions for this test, you will need to use a non-parametric test instead. Non-parametric test of rank correlations summarizes nonlinear relationship between variables. The Spearman's R and Kendall's tau have the same condition for the use, but Kendall's tau is generally referred for smaller samples, whereas Spearman's rho is more widely used. The table here shows that Pearson's R has linear relationship. It's two quantitative interval or ratio variables. Spearman rho is nonlinear, two ordinal or interval or variable data. Point While serial is linear, one dichotomous binary variable and one quantitative interval or ratio variables. Kramer's V is nonlinear to nominal variables and Candelis taus are nonlinear to ordinal or interval based. Pearson R. The Pearson product moment correlation coefficient, also known as Pearson's R, describes the linear relationship between two quantitative variables. There are assumptions that your data must meet if you want to use the Pearson R. Both variables are in an interval or ratio level of the measurement. Data from both variables follow normal distribution. Your data have no outliers. Your data is from a random and representative sample. You expect a linear relationship between the two variables. The Pearson R parametric test, so if it is high power but it's not a good measure of the correlation, if your variables have a nonlinear relationship or if your data have outliers, skewed distribution or come from a categorical variables, if any of these assumptions are violated, you should consider a rank correlation measure. The formula for Pearson's R is complicated, but most computer programs can quickly churn out the correlation coefficient from your data. In a simpler form, the formula divides the covariance between the variables by the product of their standard deviation. Pearson sample versus population correlation coefficient formula. When using the Pearson correlation coefficient formula, you will need to consider whether you are dealing with the data from a sample or the whole population. The sample and the population formula differs in their symbols and inputs. A sample correlation coefficient is called R, while a population correlation coefficient is called rho, the Greek letter rho. The sample correlation coefficient uses the sample covariance between the variables and their sample standard deviations. So this is the two difference. The population correlation coefficient uses the population covariance between variables and their population standard deviation. So this is the formula for population when we are using correlation Pearson in the whole of the population. Spearman law. Spearman law or Spearman ranks correlation coefficient is the most common alternative to Pearson's R. It is a rank correlation coefficient because it uses the ranking of the data from each variable, that is from lowest to highest, rather than raw data itself. You should use Pearson's rho when your data fails to meet the assumptions of the Pearson's R. This happens when at least one of your variable is on a ordinal level of the measurement, when the data from the one or other variables do not follow normal distribution. When the Pearson correlation coefficient measures the linearity of the relationship, the Spearman's correlation coefficient measures the monotonicity of the relationship. In a linear correlation or relationship, each variable changes in one direction at a same rate throughout the data range. In a monotonic relationship, each variable also always changes in only one direction but does not necessarily at the same rate. Positive monotonic, when one variable increases, the other also increases. Negative monotonic means when one variable increases, the other decreases. Monotonic relationships are less restrictive than linear relationships. Spearman's rank correlation coefficient formula. The symbol of the Spearman rho R is the population coefficient R for the sample. The formula calculates the Pearson's R correlation coefficient between the ranking of the variable data. To use this formula, you will first rank each data from each variable separately from low to high. Every data point get a rank from first, second and third. Then you will find the difference between the rank of your variables for each data pair and take that as the main input for the formula. In computer programs or Excel sheets, There is formula, you can use that very easily. So there are some other coefficients. The correlation coefficients is related to two or more variables or coefficients and give more information about the relationship. Coefficient of determination. When you square the correlation coefficient, you end up with the correlation of determination r square. This is the proportion of the common variance between the variables. The coefficient of determination is always between 0 and 1, and it is always expressed as a percentage. So coefficient of determinations is used to in regression model to measure how much of the variance of one variable is explained by the variance of the other variable. A regression analysis helps you find the equation for the line of best fit, and you can use it to predict the value of one variable given the value of the other. A high R square means a large amount of the variability in one variable is determined by its relationship to the other variable. A low R square means that only a small proportion or portion of the variability of one variable is explained by its relationship to the other variable. The correlation coefficient can often overestimate the relationship between the variables, especially in a small sample, so the coefficient of determination is often a better indicator of the relationship. Coefficient of alienation. When you take away the coefficient of determination from unity, you will get the coefficient of alienation. This is the proportion of the common variance not shared between the variable, the unexplained variable between the variables. A high coefficient of alienation indicates that the two variables share very little variance in common. A low coefficient of alienation means that a large amount of the variance is accounted for by the relationship between the variables. Thank you for discussion. We will discuss other research methods in our next class.